Good afternoon and welcome to the next episode on the 5HP18 rebuild. It's been some time, but I got time to do the pump today. You see a dismantled pump from a breaker. I intentionally got another pump just to be able to compare because I don't have any data on measurements on the pump from ZF. ZF just renews the entire pump, or so they describe. The pump is being held in place under the C1 clutch with all these Torx bolts. It's torque size 30. You should support the shaft and the splines with a piece of cloth, because before you want to undo those bolts, you want to give them a tap with a hammer, and that'll help you undo the bolts, because if you strip these bolts you're in trouble and you'll need another pump. So every bolt is being tapped once. And with all those bolts tapped, I'm going to put this entire pump assembly in my vise. I'm going to grip it right here, because this is an unused area, and I'll use a piece of cloth to protect the steel. With the pump body in the vise, not with too much tension, because you don't really need to hold it, I am now able to use Torx 30 to undo the bolts. I'm using a small ratchet on purpose. And I need to compress a bit more. That's one. Back to the workbench. Time to disassemble the pump by undoing all those T30 bolts. And with the bolts removed, you need to pry with a flat screwdriver. So on the side, we pry around on the pump. It's got two guide pins, so those two guide pins are going to keep the pump assembly in place. And gently, as we go around, we pry and make sure that we get those guide pins moving. Okay, that one guide pin is almost out, and then we have that other guide pin on this side which doesn't want to cooperate, so it needs a bit of convincing. And there we go. Now I'm gonna put the pump and C1 assembly over there, and here's what we're looking at. You now see two identical pumps. This is the pump that was in my car, and it did just fine for about 180,000 kilometers after its first rebuild. I rebuilt this transmission at 300,000 kilometers. It ran until 480,000 kilometers, and then I wrecked the car. Transmission was doing just fine, as I said in the previous rebuild videos. So, on purpose, I got another pump right here, just so I'm able to compare 480,000 pump to a 300,000-ish pump. This is from a breaker yard from I think it's a 2.8 version, 5HP18, so it's internally it's the same, but it has a different torque converter, different input shaft, and different bell housing. But internally it's the same. I mean, the pump is interchangeable. And why I did this is I want to make sure that when I put this 2.8 liter with less mileage pump next to my 3 liter with kinda a lot of mileage, if I would see a lot more play here, I would be able to switch to that pump. The great disadvantage of the 5HP18 is we don't have any information on the clearances on the pump. A good gearbox manufacturer tells you how much clearance you need to have right here, how much clearance you need to have with your outer gear to your housing, and how much clearance you need to have here at the crescent. But ZF doesn't tell you anything about this. ZF just says order a complete new pump assembly. And that's bad, because all of this surrounding the two gears is perfectly reusable if you see no damage. So the first thing I'm going to do is clean this up a little bit, and then we're going to compare the two pumps. you can see immediately when a gearbox has been taken care of, or when a gearbox didn't have any heavy damage, if the pump is as clean as you see this one. You don't see any metal shavings, you don't see any excessive wear on facings. As I'm using a rag, not even using brake cleaner, I'm just using the ATF on the rag, I'm getting a pretty clean pump. Alright, so let's have a look. Let's put the pump in a similar position. It doesn't matter how you assemble the pump, because as you can see, when I'm spinning the pump, you can see that the position of the notch is changing. So you can just assemble this pump any way you like. But let's put it this way. We take out that inner gear. It's stuck in the fluid, but it's coming out. And we put the inner gear exactly in the position that we have on the other pump. And now we're going to make them watch that hole. Okay. We now have a perfectly comparable situation. And now we want to see if the current pump that I was using with 480,000 on it, compared to a probably 300,000-ish pump, would have more wear. Visually, I can't see anything. So, since I do not have any reference to measure, we just need to see if we can find out if one of the pumps has a bit more clearance, and that would indicate wear. I gotta tell you, both look fine. Both pumps look fine. So, I do have a reference, and that's a Japanese transmission that I found on the web. It has like a reference of 0.15 maximum pump clearance. So let's take a look, and let's start with that 0.15. Here we have 0.15. And that Japanese transmission is not allowed to have more than 0.15 millimeter here between the outer gear and the housing. I cannot get my 0.15 in, so that's good. Same here. I'm pushing a little bit on the gear to cheat a little bit. I can't push it in, so that's good. And that transmission also has a maximum that you should not be able to put 0.15 between the gear and the inner gear and the outer gear. So let's force the outer gear, the inner gear against the outer gear. And on the face of the gear, the teeth, I can't put my 0.15 in. So that's pretty okay. Now, watch this. If I put a little bit of force here, I move the gear towards the crescent. Now that's perfectly normal. Same here. I move towards the crescent. Perfectly normal. I want to see which one is the better one. We've got the notch pointing at that bolt hole. Notch also pointing at that bolt hole. And I want to use this tooth to see how much play I got. And visually, from what I can see, is that this one has a bit more play, but that could also be just me. So let's have a look. We're going to start with a millimeter. Can't put a millimeter in. Although this one feels a bit more loose, both of them can just, maybe if I force it, take 0.55. And I'm forcing it. But this one feels a bit more tighter. So I kind of want to use this pump, because this one has a bit more wear. We've just... The final part of the pump inspection, assuming that you either have a comparative way of inspecting or you have the data from the manufacturer, is that you put a straight piece of steel on top of your pump, and you then measure the face compared to your steel, how much distance you have between the facing and your steel. And there's also a minimum and maximum for that. I don't have that data. Again, I don't have that data because ZF didn't disclose any of that data. So for now, I'm done with inspecting the pump. I know this one works because I drove with it. This one is a bit more tight, so this one is in better condition. And I'm going to use this pump. What I'm going to do now is clean the pump. I'm going to remove the oil seal, and I'm going to see if I can easily remove the bronze bushing, because I have a new one. Just to make sure that I don't screw up, I'm going to keep this plate intact, because this was the original plate. I'm going to keep the pump inner and outer gear separate so I don't screw them up. And we're going to remove that oil seal and the bushing that you see on the inside. Before I remove that bushing, I want to compare it with the new bushing and make sure I got the right stuff. Because after demolishing your old bushing, you don't want to catch yourself having the wrong bushing. So, this looks like the right bushing. That's great. And does my old bushing have a similar lock? Let's see. Guess it does. So let's proceed. Gonna put the new bushing aside. Gonna take that screwdriver I had with that hammer I had. I'm gonna see how easy that oil seal wants to come out. And with removing the oil seal, I don't want to put any stress on the outside, because if I scratch it, I get a possible oil leak. So preferably I want to go from the inside out. I need to support this we're going to support the disc with some old bearings, and this allows me to tap at the oil seal. Here's our oil seal. I had to cheat a little bit by working it out from the outside. Shouldn't do it. Here we got a ring that I need to flatten. I damaged this ring a little bit. Gonna put it between the vise to get it flat again. Let's see if there's anything else we need to look for. We've got an oil passage here. No, but that's pretty much it. And we should be able to get that bushing out now, but we gotta be wary, because apparently, from what I can see, we need to push the bushing in from this side, because it rests right there. That means we need to remove it from the other side. Let's see if we can get some distance on it. Luckily, I've got this second pump housing, so I can experiment on this a little bit with the camera. Because if your pump has been fully functional, you generally don't really replace it if you're rebuilding your own gearbox and you know your pump did a good job. That's the bushing. Here we go. Now the outside. Okay. So with the housing supported on an alternator bearing, let me show you the setup again. So we've got that ring that's behind the seal in first. And I got an old alternator bearing right on top of it, which is not really a press fit. I'm just gonna lean on it to make sure it really seats nicely. Now we've got the new sleeve bearing. The bore is clean. I don't feel any contamination on the bore. I would like to put some transmission fluid on the new bushing. Okay, so with our alternator bearing set up under the press, with the bushing lubricated, with the bore clean, I want to find an old bearing or similar that will help me get that bushing in. This one will do. It's just for the first few millimeters so the bushing grabs. And we got to be absolutely careful it goes in straight and it doesn't go in bent, because then we screw up our new bushing. So let's get started. And there we go. This is a 100% tight fit. 100% lined up with the outside. So I used an old alternator bearing as to assist me. I put the ring in. I put the alternator bearing on. And right now, if I use the old bushing, which I of course heavily damaged, so it doesn't have the right diameter anymore for the press fit. If I use the old bushing with another alternator bearing, I was able to use the hydraulic press to put the new bushing in just fine. I went a bit too far with the new bushing. To correct this, I pressed a little bit on the other side, forcing the ring that's in the middle to put the bushing exactly in position the way it should be. So I got the new oil seal right here. Naturally this is the wrong way, we're going to put it in that way. And difficult, not difficult, but thing you need to watch out for is those automotive oil seals are just industrial seals with normal dimensions and oil resistant material. There's nothing special, but they usually have grooves right here that point into one direction. And that's because the engine is always running in one direction. So by putting those grooves in, the seal protects better in that direction. In an application where you have an electric motor that needs to turn clockwise and counterclockwise, you probably don't have these kind of grooves and you have a different type of seal. So if BMW or your supplier doesn't have seals, the oil seal that you need, you can get a universal one, but you need to make sure you've got the grooves in the right direction. Very important with those oil seals is that they need to be thoroughly lubricated with oil before you install them. And the reason for this is an oil seal always leaks a tiny little bit, and that keeps the seal lubricated, because if it wouldn't get any lubrication on this area from where you have the snout of the torque converter, it would burn up. So it is normal that you always have a tiny little bit of leak, unnoticeable pretty much, on that area. To get that oil seal in properly, you need the right plastic piece, which you have for universal oil seals. But a friend of mine used a lathe and turned this plastic piece, and as you can see, I can use this plastic piece to put the oil seal in just fine. So before we start, do I have a clean bore? Yes, I do. Do I have a clean surface on that ring? Yes, I do. Is there any way I can screw up the positioning of that ring? I guess I could, because there's an oil opening here and I could cover that with this ring, and I don't think I'm supposed to. So let's put the ring in such a way that the opening right here is still visible. We put the oil seal on top, and we put our oil seal adapter piece on top. Now I'm just going to gently tap it, see if it wants to go in by itself. Just going to put a rag between it against the noise. And it's going in, so that's good. Need to correct it a little bit, because I want it to be in perfect. And now that I have it seated, I'm going back to my press. And we're going to do this real gently, because that oil seal is soft material. And we also want a perfect tight fit with the oil seal. can see the oil seal going in. Now I want to check out what we did. Okay, so it's going in just fine. No real differences anymore. Alright, that's good. That would mean that if I put my adapter piece on it, yeah, looks pretty okay now. So now I can just continue. Put it in the middle of the press. There we go. You shouldn't overdo this. It just needs to seal. This is not a bearing. Right, to summarize, I've got my oil seal in. It's perfectly tight fit right here, exactly on the surface, but it arches over a little bit on this area. Now I actually saw that the oil seal that I removed had the same thing, so it probably doesn't matter, but I want to try and see if I can get it perfect. And that's a lot better. Perfect, tight fit right here. It doesn't go in the bore, it doesn't arc over the bore. It's 100% tight around the bore. And why this is important, if you really want perfection, the oil seal has these little lines on the side, which acts like little oil labyrinths that trap the oil so it doesn't leak out of the outer bore. Right on the inside everything feels nice, no damage. The ring is in between as it's supposed to. And we already saw that we had that sleeve bearing done correctly. So, basically, this pump body now has a new bushing and a new oil seal. We want to give this a thorough cleaning. And as you see, I'm not using any agents. So, this is how well this box was doing. This is actually the box from the breaker yard. But since everything went smooth, I'm just going to use this plate. And with everything clean, we're going to install our pump ring and pump gear. We dipped them in ATF because in the first few seconds this gear is going to run without any lubrication. That's just something we got to be realistic about. And that's basically the pump we're going to use. Apologies for this final part. I had to narrate it from behind my computer because the sound on my camera went bad, so I guess it's time for a new camera. What you see me doing here is putting the pump back together after I lubricated the surface and the gear of the pump. You use two hands to push the pump together. The two fluid openings on both sides need to face each other, but you'll see that if you have any other position, the guide pins won't grab in the right hole. So when you have the fluid openings matched up and the guide pins grab, you hold the pump together with two hands. You then put one Torx bolt in the pump and you torque it down a bit so it holds the pump together. Then you just put all the Torx bolts in. You then use a crosswise pattern to torque them down. The official torque spec is about 10 Newton meters, but since everything is oily, this 10 Newton meters on your wrench is very unreliable, and I would just recommend you put your wrist on a small ratchet and you just torque it down with some feeling in your wrist. You will feel when you're going too far. Don't overdo this since they're only small Torx bolts. Thanks for watching this video on the pump. Please subscribe to my channel. The final two videos will be on brake band adjustment of this transmission, the tailpiece and end play.